Our next unit is a linear unit, so we're going to learn about everything related to lines. A line is a type of function, so that's what we're starting with. Our learning target today is functions and function notation. So a function is when each input is paired with exactly one output. So if you look at the bottom of your page right here, you'll see I have an example of a function. This is a visual representation of a function. I like to call it the function machine. So if you look at the top of the function, that's where the input goes. Another word for input is domain. So you drop the input into the function. If you look inside the green box there, in this case, our function takes whatever is dropped into it and it adds 4 to it. And then it spits out a value. So if you look at the orange triangle, that's what comes out of the function. Another word for output is range. So for example, if we drop the x value of 2 into the function machine adds 4 to it and spits out an output of 6. And you can see the other values that would be paired up. The reason this is a function is because when you put an input into it, you will get exactly one output. When you add 4 to a number, you get a unique answer. If you take 2 and you add 4 to it, you can't get 2 different answers. You can only get one answer. So that's what a function does. It gives you exactly one output or range value for each input or domain value that you put into the function. What we're going to be focusing on is what's called function notation. So if you take a look at this f of x right here, this is not f times x. We use parentheses to represent multiplication. This is what's called f of x. It's function notation. So x is the input, f of x is the output. So for example, for our function machine down here, if we put the input of 2 into the function will take that input, add 4 to it, and it will give you an output of 6. So this function evaluated at 2 equals 6. There might be a lot of new terms that I'm saying here, but as we use them over and over again, hopefully you'll get to understand what they mean. Starting off by practicing evaluating our function notation, we're going to take a look at substituting the x value into the function notation and then using order of operations to get our answer. We're also going to look at different ways to express our function notation, as well as talking about domain and range. Remember, domain is the input, range is the output. So we're going to start by substituting each of those x values into the function for x. So notice I took this x value of -2 and I put it into the function notation for x, which means on the other side of the equal sign I'm also going to substitute that -2 value everywhere there's an x. So we're going to replace our x with -2 and evaluate the function. Order of operations, we'll multiply our 3 by -2 first, and then we'll subtract 1 to get an answer of -7. Once I have all of my answers, then I'll put it as a table, but I can express each answer as an ordered pair right away. So my input was -2, that's my x value, so that goes in the first spot in the ordered pair. It's also called the domain, and then my output or my range value is also a y value, so that goes as the second number in my ordered pair. Next, we're going to evaluate for -1, replacing x with -1 everywhere we see it in the function notation, as well as in the equation. 3 times -1 gives us -3, minus 1 gives us -4. Setting this up as an ordered pair, our input, our x value was -1, and our output, or the y value, was -4. Our next x value is 0, substituting that 0 into the function notation, as well as into the equation, replacing our x value. 3 times 0 is 0, and 0 minus 1 is -1. So we get the ordered pair 0, -1. Our next x value is 1, substituting that into the function, replacing the x everywhere we see 1. We get 3 times 1 is 3, 3 minus 1 gives us 2. So for an input of 1, our function gives us an output of 2. And our final x value was 2. Substituting that into the function for x, we get 3 times 2 is 6. 6 minus 1 is 5. So again, when our input was 2, our output was 5. Next, we're going to put all of these values into a table. Some of you also might have called this a t-chart. When I had an x value of -2, my y value, or my f of x value, was -7. When my x value was -1, my y value, or output, was -4. For an input, or a domain of 0, we had an output of -1. For an input, or an x value of 1, we had an output of 2. And for our final input, or domain of 2, our range value was 5. Last thing we needed to do was identify domain and range. Remember, the domain is the input, so all of our x values give us the domain. The range is the output, so our y values, or our f of x, give us our range. We'll take a look at one more example. This time our function has a square root, so we need to remember how to evaluate our square roots. So again, substituting those x values into the function in replace of x, we're going to take the square root of -9 and then add 8 to it. The square root of -9. Remember what a square root means. It means the answer is a number that you can multiply by itself to get what you started with. So think about, what number can we multiply by itself to give us -9? Most people think the answer is -3, but if we take -3 times -3, we get +9. If we take +3 times +3, we also get +9. There is no square root of a negative number, so this would be what's called undefined. If you try and take the square root of a negative, or if you try and divide by 0, you will get undefined for your answer. So let's substitute those positive numbers in instead. Replacing x with a 0, we get the square root of 0 plus 8. So what number times itself gives us 0? That answer is 0. So we have 0 plus 8, or 8. So our first ordered pair is for an x value, or an input, of 0. We get a y value, or an f of x value, or an output of 8. Substituting our 1 into the function for x, the square root of 1 is 1. 1 plus 8 gives us 9. So for an input of 1, we get an output of 8. Substituting 4 into our function for x, taking the square root of 4 and adding 8. Square root of 4 is 2. 2 plus 8 gives us 10. So for a domain value of 4, we have a range value of 10. Our final x value that we were given is 16. So we're going to take the square root of 16 plus 8. The square root of 16 gives us 4, and 4 plus 8 gives us 12. So for our input of 16, or our domain, we get an output, or a range value, of 12. Putting those into a table, another way to make a table is to make it sideways. Anytime you see a table of values, the x value is on top and the y value is in the bottom row. I'm not going to list our value of -9, as we got an undefined y value, or f of x value. So I'm going to start with 0. We got 8 when we put 0 into the function. When we put 1 into the function, we got 9. When our input was 4, our output was 10. And finally, for an input of 16, our output was 12. So again, taking a look at our table, the top row, the x values give us our domain. Those were the inputs for our function. The bottom row, the y values, the f of x values, the output, give us our range. Here's a U-try question for you. Make sure you follow order of operations when you look at this one. Grouping symbols first, and then that power.